Hello, my name is Caoimhe Hickey. I work for Geological Survey of Ireland, and I'm here to talk about the CatchmentCARE project. So I'm mainly talking about the groundwater work, which is done by the groundwater team, which is myself, Tally Hunter-Williams, Paul Wilson and Sean Burke of BGS. So the talk outline, I will introduce the CatchmentCARE project and just briefly talk about its aims, the funding and the partners involved. Then I will introduce the catchments. I will give examples of water quality improvement works occurring in the catchments. I will focus on the groundwater works, and then I'll move on to a case study, the Arnie River catchment, which is this catchment here. I will talk about the spring monitoring that's underway at the moment, and then I will link this groundwater works to other partners and to the project as a whole. And I'll briefly try and give you a flavour of the education and outreach aspects. So CatchmentCARE, CARE stands for Community Actions for Resilient Ecosystems. The main aim of the project is to improve freshwater quality within the Northwest and Naban International River Basins, so all of the catchments are cross-border. This will be achieved through the development of water quality improvement projects, the installation of a new network of greater than 50 groundwater monitoring sites across the region, and this is to look at the interactions between groundwater and surface water and to understand the groundwaters in the area. So this will be done by a combination of policy actions, catchment actions and community actions, and the community actions are very important in this project. The three main criteria that we must focus on is that there will be a measurable impact on water quality and that this is transferable beyond the three catchments, and also that there will be a project legacy. So the funding structure, it's a EU Interreg funded project with a budget of almost 14 million, and over 2 million has been provided by the governments on both sides of the border. It's a 5-year project. It started in November 2017 and it's due to finish in October 2022. We've applied for a 6-month no-cost extension due to COVID. So who are the partners? Well, Donegal County Council are the lead partner. They're looking at management of the whole project. And then each catchment has a catchment officer. And the catchment officer is kind of like the liaison person between the farmers, the landowners, the community incentive, the community schemes, and the partners. And so the catchment officer for Armagh City, Banbridge and Craigavon Borough Council, which we call ABC, is looking at the Blackwater catchment, and they're involved mainly in the communications and engagement aspects of the catchment. The Arnie catchment officer is from Inland Fisheries Ireland, and they're looking at scoping and works mostly in the Arnie catchment. The catchment officer for the Finn is from the Lochs Agency, and they're again looking at the actions and scoping and actions in the Finn catchment. The research element is being looked at by Ulster University. They're looking at things like willow plantations, lake remediation and nutrient cycling and so on. I've previously mentioned that the BGS, GSNI and Geological Survey are looking at the groundwater aspects of the project, and then AFBI are the agricultural link, and they're looking at nutrient transport and overall project legacy. So an introduction to the catchments. They were selected, so you can see the three catchments there. They were selected due to water bodies failing to achieve good ecological status under the Water Framework Directive. There are other catchments in the region that are being looked at for various reasons. So for example, the Derg catchment, which I'll show you on the next slide just below the Finn, is being looked at by the groundwater team because there's another project, source to tap project going on there. And they're looking at MPCA in surface waters, and they want to see if it's in groundwaters, and if not, perhaps if the groundwater could be used as a water supply. So we're looking at the gravel bodies there. So I only have time to give you a very brief flavour of the works that are happening. So probably the main one is the riparian and in-stream works. These include fencing, drinkers, planting of saplings, meander complexes, pool creation, and so on. You can see some examples of pictures. These are all taken from the CatchmentCARE catchments. There's some fencing, bank stabilization. You can see some meander and pool complexes and so on. And I suppose we all know the benefits of these. Not only do they provide habitat and increased biodiversity in the catchments, but they also uptake and intercept a lot of the nutrients that would otherwise run off down into the river. And they also have, other important aspects like flood management and slowing down runoff. So soil nutrient management, this is being led by AFB and ABC. So they looked at over 400 fields and 17 farmers received tailored nutrient management advice. And they were looking at things like soil pH, soil phosphorus, and soil potassium. So they found that more than 2/3 of the field had above optimum levels of soil phosphorus. And then there are other areas of nutrient deficiency where you can see they're spreading lime to try and counteract this. Another example of the water quality improvement works are willow plantations. So there's 3 sites for willow plantations. One is up and running and is taking wastewater from an wastewater treatment plant, and it's been put through the willow plantations, and we can already see really good results in the water quality. It's a big improvement. One site has been planted at the moment, and they're looking for a 3rd site. In the Finn mostly, where the aquifers are quite poor because it's quite old Precambrian rocks, we have a lot of sheep up in the upper reaches of the catchment, and so sheep dip was actually shown to be a big problem, the sheep dip runoff. So they've done a lot of sort of educational works around best practice, educational videos, demonstration days, and so on. So they're just some of the examples of work going on in the catchments. So moving on to the groundwater monitoring stations. So far we have 32 monitoring points. They have been established at 23 groundwater monitoring stations. The reason for the difference in number is a station could have up to 3, usually 2 or 3 boreholes. And these are like nested boreholes, targeting different depths. So we've got the shallow or superficial transition zone. We've got maybe a mid-range, 30 to 50 meters and so on, and then a deeper borehole, 80 to 100 meters, depending on what we find at the site. They're all different. And as well as the boreholes, so we've drilled 15 boreholes. We have 2 pre-existing ones. We also are monitoring 15 springs. So 3 geophysical surveys were done to help locate these boreholes. So for example, in the Blackwater catchment, we wanted to look at the effects of the igneous dikes. So we, with the help of TELUS, did some geophysical survey to look at locating where the actual dike is and to look at the sandstone and the limestone on either side of it, for example. And I mentioned the DERG, the Source to Tap project, the NPCA in the rivers. They did geophysics again, electrical resistivity, to see how thick the subsoils were, the sand and gravel, to see if they could be used as an aquifer. So just an example of the groundwater works that are still ongoing. You can see what I talked about here. This is a groundwater monitoring station, and there are 3 individual boreholes in it. Some of these are artesian. You can see some of the preliminary pump tests that were done, just for a very quick pump test, just to get a feel for the aquifer. Same thing with the Finn catchment. You can see some of there was some just basic logging of the boreholes to look at temperature and conductivity and so on. So a sample of some of the monitoring data that we're getting back. Most of these are telemetric, and they will soon be up on the GSI groundwaterlevel.ie website in real time. We just need to get the ordnance data, survey them in. So you can see the kind of information. You can see that for the exact same rainfall events, recharge events, you've got quite different responses between 2 different monitoring stations. And not only that, but in both stations, actually, the bedrock water level is higher than the superficial water level. So that's quite interesting. It's sort of demonstrating that the bedrock is confined in this area. Okay, so lastly, moving on to the Arnie River catchment, the case study. So this is a carbonate-dominated catchment. And again, you can see that the catchment is dominated by these 2 big lakes, Upper and Lower Loch Neen. The flow of water is from the east towards the west. The Arnie River flows from Lower Loch Neen to the Erne, about 15 kilometers away. The catchment in total is about 300 square kilometers. This is a very large glacial trough. That's where the lakes are sitting in. So it's just kind of cut across, and you actually see lots of limestone sort of walls or gorges sticking up because of this. The bedrock of the Arnie, it's all, as I said, carboniferous, mostly Donantian. You can see lots of shales and sandstones in the uplands. They're forming the uplands, and here again. And as you move lower down in the catchment, you've got a lot of limestone. This is pure carboniferous limestone, Dartry limestone. And then lower down again, you've got shales, so the Bundoran Shale Formation. And the aquifers reflect the geology. Sorry, this map is a little bit strange because I have the BGS, GSNI aquifer categories on this 2/3 of the catchment, which is in Northern Ireland, and this is the GSI aquifer category. We actually are working to make a All Ireland aquifer map, and this is going to be a nice project as part of this project. So you can see the uplands, the shales and sandstones are mainly PL, PU, poor aquifers, little storage. The Glenade sandstone is a better aquifer, and it's LM from GSI and moderate potential for GSNI. And then you can see a lot of the shales down in the lower catchment, limited potential, which would be kind of a poor aquifer. But all the blue areas are the karstic limestones, and this really dominates the hydrogeology in the area. If you've never been to this area, it's a fantastic area for karst. This is the uplands in the Quilca. This is a still from one of the videos the CatchmentCARE produced. They got a drone, and I was just in awe of the drone imagery here. You can see huge enclosed depressions, quite deep. They're kind of almost potholes. It's famous for the Marble Arch cave system, but there are literally like tens and tens of caves in this area. Some are really big. You can see the caver there dangling on a rope. So it's a fantastic area for karst, and I was only too happy to get out there. So looking at the water framework directive status, there are 9 groundwater bodies in the area. So it's the first diagram. And you can see that 2 of these are a poor status. This is due to failing the groundwater dependent terrestrial ecosystem and surface water tests. One has improved, the Marble Arch groundwater body, which is great. And the lake bodies, both of them, they're a poor, the lake water bodies are a poor and bad status. The upper lake is mainly poor due to forestry activities. And again, this river here, sorry, you can see my pointer. This river is the Rue. So some of the river water bodies are moderate as well. And the Rue is at moderate status. It's improved, but it's still moderate status. And the main pressures are the usual: is forestry, agriculture, domestic and urban wastewater treatment. And for example, the Rue has been highlighted as a place that is suffering from domestic wastewater treatment, effluent, sorry. So I won't go into detail about the water quality improvement works because I've kind of given you a flavour of them before, but these are the ones specific to the Arnie. The IFAI are overseeing them, and they involve like over 500 drinkers, riparian zones, 12 kilometres riparian zones, and so on. And they're targeting the scoping work to prove that the 3 main areas that needed to be looked at are the Drum Harif Burn, the Rue, as I mentioned before, and the Arnie river body and its tributaries. So moving on to the groundwater work, as I said, it's a karstic area. And so generally in a karstic area, you have large springs. Because there's a lot of large springs at the surface, it was obvious then we didn't need to drill boreholes to get at the groundwater. So it was great. So one of the first tasks was to review all the desk study sources and to try and find the springs, and then to actually go out and assess the springs, go out and visit them all. So over 20 springs were visited and surveyed, and the initial hydrochemistry was taken of them. And so as you can see, the results, most of the springs are in the carboniferous limestone or just off it. I have included a well up on the shales and sandstones here, and also a well on the Bundoran Shale Formation. So looking at this, a subset of this then was deemed suitable for a data logger. So there's 15 data loggers installed currently and a barometric, and I would like to do one here and maybe one in the sulfur well. And they are currently monitoring every 15 minutes. They're taking level, electrical conductivity and temperature. And you can see those same sites then are being used for the hydrochemistry sampling. So I'll talk about the hydrochemistry monitoring in a few minutes. And also then a subset of these 3 or 4 sites then are going to be chosen for the continuous monitoring of discharge. And also the blue sites are being used, the bigger data set is being used for discharge monitoring every month. So there's one monthly discharge monitoring, and this can potentially be event-based. And then there's 3 or 4 sites that are going to be continuously discharge monitored. And this is great because it means that I can tie in my level from my water loggers with actual discharges. So I mentioned the hydrochemical sampling. So in the project, the groundwater aspect as a whole, across all the catchments, the 50 boreholes and the 12 springs will be monitored in total. And there'll be 6 rounds of sampling done. The first round has been completed and we got 17 boreholes. That's 15 boreholes that have been drilled that I talked about previously, 2 pre-existing boreholes in the Arnie catchment, the 9 springs and 9 of the 12 springs, sorry, and a dug well. Round 2 is deferred to April, and hopefully it'll be happening at the end of this month or the start of May. So they're looked at, there's 5 different suites, there's a whole host of parameters being looked at. And this is the first time groundwater has been monitored in some of these areas, and we're liaising with other projects and partners such as the Source to Tap, which I mentioned before, which is looking for the MCPA. So they have we've left them a special top that they can sample once a month. So just some preliminary results. This is from the Claddagh River, which is basically the outflow from Marble Arch Cave and a lot of other caves. It's a very large river, it's very flashy. So it's just a large spring resurgence, and it's basically 3 sinking streams coming off the Quilca. They sink underground and they flow through the Marble Arch. So as you can see, it's extremely flashy. So as the level rise, the electrical conductivity falls almost to, very low river levels, just rainwater really is just pumping through the system. So it's very, very responsive. And when I plotted the Claddagh River, this is the Claddagh River, I plotted it against another river in the area, the Lurgan, which is spring fed, but it much further downstream. It's quite a big river. You can see that they were almost identical, the signatures and the responses. So basically the Claddagh springs there are essentially acting as a surface river. And then just to compare with another spring, the Boron Spring, which is the headwaters of the Roo, the tributaries of the Roo. Again, this is very karstic. It's fed by large sinking streams and caves, but there is a more diffuse element, and you can see the diffuse element being picked out in the kind of slower response times. So instead of the electrical conductivity dropping straight away as the freshwater pulse comes through, you get this slight increase and then it falls. And actually this is quite common in karst aquifers. So zooming on this area, just to show you some of the information that we can gather from looking at the hydrographs. So for here, we can see that the Claddagh River, this is the Claddagh River again, responded within 14 hours to the peak of rainfall. So it was 14 hours from the peak to the dip in electrical conductivity. And if we didn't have any more rainfall events, we can kind of interpret the recovery, which is about 5 days. So this is just a flavour of some of the information we can gather. And when we have more information, we can start to do more complex recession analysis and so on. So the hydrochemistry results, we can see again, there's only been 1 sample round done, but as you would expect, quite a high cluster of calcium bicarbonate signature there, which you would expect. But also you can pick out the 2 wells that aren't on karst lime. So Boylan's well was up on the shale and sandstones to the east of the catchment, and Sulphur well then to the west of the catchment is on the shales. So 5 out of the 12 samples had exceedances for water quality, for things like ammonia, which was actually quite interesting, and some of them are related to the forestry. They're up near the forestry. And yeah, we were able to group the springs then, in terms of EC, just to see the Sulphur well, obviously very high EC, And these 3 were 2 samples taken from one borehole and 1 sample from another borehole. And because these boreholes aren't being pumped, the water has just been sitting in the rocks, so very high EC, but it was just interesting. So I'll move on now to the linkages with other partners in the whole kind of catchment approach. So this work complements the other work in the catchment. Groundwater has a very large influence on the rivers and lakes in the Arnie. So now we have a baseline data set of the hydrochemistry of many springs in the Arnie, which are the headwaters to the rivers. This fingerprints the water coming out of the ground. And so when we start getting a handle on discharges and what's in the, what's found and parameters in the springs, we can start maybe trying to calculate loading. And this would be very important for some partners such as Ulster University that are looking at nutrient recycling and nutrient management in the lake. Other things like the temperature data sets that we are collating now are very useful for the ecological aspect for fish, and this is of interest to IFI. We're also working closely with community incentive scheme projects, the CIS projects that are currently underway in the Arnie. So one of these is Speleological Union of Ireland, SUI, applied for funding. This is the community-led schemes. We were extremely lucky to get Les Brown and John Kelly, who are both locals and interested in this, to apply. And they wanted to undertake a comprehensive water tracing in the Arnie. So this is fantastic news for us. Of course, we were delighted. So far, 2 large water tracing experiments have happened. They were kind of repeating pre-existing traces, but in one, we found a new route because there was monitors in this cave that wasn't previously known about in the last trace, and the dye went via that cave, so that was very interesting. And the other one, and in this one as well, we were able to get flow rates for the first time. We never had flow rates before. We had in situ data loggers, fluorometers recording the dye as it passed through, so they're very accurate flow rates, and we could see that they were really, really fast, 3.6 kilometers per day. This has obviously huge implications for water quality and for management of water quality. The trace to the Roo, this is the Roo River here, that is the priority action area, and the river I talked about before. It's one of the tributaries, starts in the Brawn Spring, and this actually was traced from outside the Arnie catchment. So we can see the Arnie catchment boundary is wrong. So we need to redefine that. Again, huge implications for water quality, especially if we can actually fingerprint the water coming out. So the upcoming work now, in close collaboration with the groundwater team, will be redefining this Arnie catchment boundary and the Roo to see exactly where it's being fed from. And then we'll move on to the Belmore Mountain area because there's a lot of springs there and there's been no tracing done. So the catchment area for them is unknown. These are just stills from the educational video. So again, they're big into education legacy. So every time something is done, there's outreach days, there was a dye tracing demonstration day, and there were videos. There's very nice videos online made of water tracing. And again, you can see some of the examples of that here. Here's Paul Wilson talking as part of the River series. This is a series for school children. It's part of the curriculum, and it breaks down the river into 5 parts, and it's a very nice program. He's talking there about the springs at the Marble Arch, and they are doing the second round of this in now. Actually, they're currently filming. They're just waiting for our restrictions to be lifted, and I'll be talking about the karst aspects as well of the river. You could see some information panels. Information panels that that are up around the catchment. But I just wanted to show this one because there's a large groundwater aspect to it, so it's been fed into. And also, the last thing, especially for legacy, is we are doing a large groundwater visualization project, and this is in conjunction with a team that are really big on VR, virtual reality, AR kind of immersive technologies. And the idea is you put on a headset and you literally dive into, let's say, Marble Arch Caves, or you follow the route that a drop of rain might take, or you go down a swallow hole. But it's not just for the karst. We're looking at for the 3 catchments, so it'll give an understanding of how to pump a well, how maybe the aquifer fills up during rainfall events, and so on. So we have a series of modules that we're developing at the moment, so it's all pretty exciting. Okay, I think I'm running out of time. So if you want to know more, the CatchmentCARE website is really excellent. It's got a lot of information up there, and there's a lot of videos and things to look at. And also we are having CatchmentCARE week, the 18th to the 20th of May, not quite a week, but day one is groundwater. So if anyone's interested, I'd strongly suggest to come along to that. Thank you very much. Any questions? Thank you.